which carries the heavy currents to drive the motor, and a control circuit, which uses lighter wires that control the heavier circuit. And to do this, we use a solenoid. The principle behind the solenoid is that a small current is used to turn on a bigger current. And if you're familiar with relays, then it's exactly the same idea. A solenoid is simply a tight coil of wire that generates a magnetic field inside itself when it's powered on. That magnetic force will pull a piece of iron into its center. A starter solenoid uses this exact design, and here's one that I've cut open. You can see that there's a coil of wire running around inside, and inside that coil of wire fits a plunger. And when we turn on the current to the solenoid coil, this terminal is a positive, and like usual, the casing of the solenoid acts as the ground. As we turn on the current, the plunger is pulled in, and it's pulled in with quite a lot of force there, as you can see. When we release the current, the plunger pops back out. Now, at the end of the solenoid is a push button, which is just inside the coil. And when the plunger is pulled into the solenoid, it pushes on that switch, which connects the heavy current to the starter motor. On the back here we have two terminals, and one terminal brings power from the battery's positive terminal, and the other terminal runs to the starter motor. And when the button is pushed, this big hefty piece of copper bridges the two copper terminals here, and that takes current to the starter. The starter runs. In some cases, the plunger will directly bridge these terminals, but having the push button setup that we have here and the separate area where the contacts are made keeps any sparking or arcing in its own little area here. We've seen the two big terminals on the back of the solenoid, and there's a third smaller terminal here. And that third small terminal is used to turn the solenoid on and off. It's called the S wire, or the S terminal, the S being for signal. And the wire from this small terminal leads up to the ignition switch. And as we said, with most electrical systems in the car, the solenoid is grounded via its casing, so we only need one wire to control it. A current flows down the signal wire, in around the solenoid coil, and then back to ground through the chassis of the vehicle. It's quite common for there to be two coils inside a solenoid, a strong closing coil that pulls in the plunger, and a second weaker coil which holds it in position, because it takes a lot more energy to pull the plunger from outside the coil into it than it does to hold it in position. And where the contacts for the starter are made, a switch also de-energizes that pull-in coil, so it saves a bit of power from the battery that's not needed when the starter is actually cranking. But don't worry about that, because if the solenoid coils aren't working, then you're replacing the whole solenoid, or probably the whole starter assembly. If you've ever tried to start a car with a flat battery, then you've probably heard a repeated clicking sound, this that's not clicking sound, click, 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 click sound, and the engine doesn't start. And that clicking is the solenoid moving, or the plunger moving inside the solenoid. Now, with a good battery, the solenoid moves once to start the motor. So it moves inside, clicks, the motor runs, and if you listen carefully, you'll hear that click before the starter motor starts running, and it drowns it out with the whirring sound. But when the battery is discharged, there isn't enough power to supply the massive current that the starter motor needs. Now, the solenoid doesn't need much power, so it still plunges. And that turns on the starter motor. As soon as the motor's turned on, it takes all the current from the battery in an attempt to move. But there isn't enough current to power the motor, and there isn't enough current left, or there isn't enough power left in the battery to hold the solenoid closed. So it's forced back open by the spring, and the motor's disconnected. But now, with the motor disconnected, there's enough power for the solenoid. So it plunges back in, energizes the motor. The motor can't run, but it takes all the power, solenoid pops out, and this process just continues. And that's the clicking that you hear as you attempt to start a car with a flat battery. So, if you're sitting in a car with a pack of velociraptors bearing down on you and the car won't start, you just hear this clicking noise, just think of the beauty of this solenoid mechanism. So far, we have a starter motor that can be switched on and off, and through the reduction in gearing, it has the torque to turn the engine over. And with this design, we can start the engine. But the engine runs much faster than the starter motor, and with the setup that we've already discussed, the starter motor would be permanently meshed with the flywheel, and after the engine has started, it would be driving the motor around in a situation called backdrive, where the flywheel is driving the starter motor. Now, driving the starter motor all the time would be a total waste of energy, but more importantly, it would tear this motor to pieces because it's designed to do the driving and not to be driven. Take a look at the video of the starter in action from earlier. You can see the pinion engages the flywheel, then spins, and then disengages the flywheel when we release the ignition. The pinion moves in and out when the ignition key is turned on and off. Unfortunately for us, we already have something moving in and out when the starter is engaged. That's the plunger inside the solenoid. Now, you might have noticed that there's a small white pin on the plunger, and it hooks to a nylon lever, which I need. I go find this nylon lever. This pin on the plunger hooks to a nylon lever that pulls the pinion gear in and out. And this lever is a fork that fits over a ring on the shaft of the starter's drive gear. And the layout of the plunger and the fork mean that the pinion is moved into mesh with the flywheel just before the motor is turned on. This is called a pre-engagement system because the gears are engaged before the motor runs. As the pinion moves, sometimes we'll be lucky and the pinion teeth will fit into gaps on the flywheel, the ring teeth here. But we can equally be in a situation where the two gears clash and the teeth bang into each other. There are three ways that this situation is handled. The first is with a small bevel on the pinion gear here, which means that as it clashes here, it will tend to be guided, just a slight rotation to bring it into alignment. So if we're slightly misaligned here, then that small bevel will hopefully correct things. The second way that this clash of gears is handled is through a slight twisting in the pinion. So let's look again at the starter engaging in slow motion. Can you see that there's a slight rotation of the pinion as it moves along the shaft? That's achieved with this helical twist on the splines here on the armature. As the fork pushes the pinion assembly along, it rotates slightly on these splines, and combined with the bevel on the teeth, it's quite rare that the pinion won't engage, but it is still possible. And to handle this situation, the pin on the solenoid plunger has a spring. When the gears have collided and they're not interlocking, the plunger isn't going to make it all the way to the motor contacts. So the solenoid keeps pulling, and this spring is overcome, and it's a very strong spring, allowing the plunger to make it to the contacts and switch on the starter. As soon as the motor spins, our gears will pop into mesh and the flywheel can spin. It's brilliant. Now, we're almost there, but there's one final challenge that the starter needs to engineer around. What would happen if someone keeps the ignition key turned after the engine has started? At the moment, the starter would stay connected to the flywheel and it would be forced around by the engine until we release the ignition. Now, I'm sure you're all saying, oh, I've got super fast reflexes. I release the key immediately when the engine fires up. Well, what about your gran? Well, she's probably got super fast reflexes as well. But anyway, we only want the starter motor to be driven one way. The motor should turn the pinion, but the pinion should not turn the motor. And actually, what we want to happen is exactly the same as on a bicycle. You know, when you're on a bicycle, power from your feet should turn the wheel, but the wheel should not turn your feet. And this is achieved with a free hub on a bicycle. We don't even think about it, but it's a type of one-way clutch. Force only goes one way, from the pedals to the wheels. The starter motor also uses a one-way clutch, a design called a sprag clutch. It's this cylinder that looks like a bearing, and it looks like a bearing because basically that's what it is. There are a few different types of one-way clutch, but they all work on pretty much the same idea. The clutch is made up of an inner race and an outer race. The inner race is connected to the pinion and the outer race to the motor. The two races are separated with little wedges called cams or sprags. Turning the bearing one way causes these little sprags to rotate and get jammed, locking the inner race and the outer race together. So the outer race is now propelled around by the inner one. This is how the motor turns the pinion. But turning in the opposite direction makes the sprags rotate in the opposite direction too, and they don't bind up. The outer race is free to rotate, and since it isn't locked to the inner race, it can just freewheel. So when the pinion is running faster than the motor, this clutch stops the force being sent back to the starter motor. That's not quite everything. Every car built since about 2005, and many built before then, will have what's called a starter safety switch, or a neutral safety switch. This switch prevents the starter from running when the vehicle is in gear, and the idea behind that is that accidentally starting the car in gear would cause the vehicle to jump forwards and potentially set off driving on its own. Now, there's loads of reasons why this is bad. You might lurch forward a couple of feet and hit a car in front or a garage wall, or a kid left in the car could start the vehicle driving by messing around with the key. The safety switch sits between the ignition switch and the solenoid, keeping the circuit open unless the safety switch is engaged. On an automatic vehicle, this switch is on the transmission, and it's closed only if the transmission is in neutral or it's in park. Mechanical switches for automatic vehicles also stop the ignition key from actually turning in the barrel, and those are called interlock switches. With a manual vehicle like this one, the switch will be on the clutch pedal, and it only actuates when the pedal is fully depressed. There's often another switch on the clutch pedal for the ECU, and that ECU switch makes contact as soon as the clutch is pressed, even slightly. So if you're rummaging around down in the footwell checking the clutch safety switch, just be sure that you've got the right switch. Let's take a look at the starter system as a whole. When you turn the ignition key, that acts like a switch, and current flows through that switch to some sort of safety switch, either on the clutch pedal or on the transmission. The safety switch stops the car being started in gear, and with the ignition and safety switch closed, power goes to the solenoid. When the solenoid is engaged, it pulls a plunger. The plunger uses a lever which pushes the pinion into mesh with the flywheel, and when the pinion is engaged, the plunger moves a bit further and switches on the current to the starter motor. The starter motor runs, starting the engine, and when the ignition key is released, a strong spring in the solenoid pushes the plunger back out, turning off the starter motor and retracting the pinion from the flywheel. So we got through a lot there. We'll come across planetary gears again on the differential. We'll meet solenoids on various valves and actuators elsewhere around the car, although if someone talks about a solenoid in relation to a car, they're almost certainly going to mean the starter solenoid. And one-way clutches, well, they're just cool, but they're also found in automatic transmissions. And of course, you know absolutely everything about starter motors. Now, the starter uses a load of power from the battery, and we need some way to recharge that battery once the engine is running. So next, we'll talk about the alternator and how it generates electricity. Guys, if you like detailed videos that go really into the nitty-gritty of how mechanical things work, then jump over to howacarworks.com, where we've got a full video course that takes you from A to Z, from starters, no, that's S, from alternators to something that begins with Z. But basically, we'll teach you everything that you need to know in mad detail, just like this episode about the starter. So if that's what you enjoy, you'll learn it all. Come and visit us over there.